This video is to go over homework 3B, lesson 308, problem number 7. Decide whether each statement below is true for all cases. If you decide it is not generally true, do one of the following. 1. State that it is never true. 2. State that it can be true for special cases. And make sure to justify your answer with an explanation and examples. So for example, part A, it says cutting a triangle along a median forms two triangles of equal area. So take triangle. Median is the segment from the midline to the opposite vertex. So if you cut that median, then you'll have two triangles. And would that area be the same for all cases? So it is obvious that it's true for isosceles isosceles triangle, because that's going to be the same as perpendicular trapezoid, perpendicular segments by definition. So that we have the same base. We have two triangles with the same base and the same height. But is that true for all triangles? If so, say yes. If not, say never be true. Well, it cannot never be true because it's at least true for isosceles triangle. But so the question is if it's true for all cases. So that's problem 7. Problem 8, refer to 7 shapes below. So you should have 7 shapes. And use a ruler to measure for part A through H. If you don't have one, you're more than welcome to come to my class and borrow it. Measure all heights and lengths and everything. And to see if part A, find 2 shapes with equal areas. So find 2 shapes with equal areas. And why? How do you know? Explain that. Part B, group the shapes by area. So if you get the one, group those shapes with the same areas. And the C is the area of shape greater than, less than, or equal to the area of shape D. So for example, so look at A, that is a rectangle. Figure A is rectangle, and figure D is parallelogram. Would that shape the same or not? If so, explain why. If not, explain why. Do the same thing for A and C. Would that be equal? Or would A be greater, or would A be smaller? So you can do that for A as well. That's actually part D. For C, you can do is area of A equals C, or is A greater, or A is smaller. So that's number 8. Number 9, give each value for right triangle shown. So problem 9, we have right triangle with 3, 4, 5 centimeters. And what's the height for this triangle? Again, height doesn't have to be straight up like this. You take whatever, for example, if you take any triangles, and if you take any base and you take the perpendicular line from the opposite vertex, that's going to be the height. Also, if you take this base, then the height will be perpendicular line from the opposite vertex. That's the height. So the height doesn't have to straight up vertically, and at the same time, base doesn't have to lie horizontally. So be careful with that. Once you find the height, all you have to do is multiply the base and divide it by 2. That's how you get the area of a rectangle. And part C is take it for other problems. So I'll give you a hint. Part D, problem 10, sorry. We have one triangle XYZ with the height 4 units, base is 7.5. And we have parallelogram with the AB equals 4 and BD equals 4.5. And yeah, so the question is, are these have the same area? Well, these two figures have the same area. Then what would be the height for this parallelogram? Okay, so it's easy to find the area for the triangle because you know the base and the height. But without knowing the height of the parallelogram, you cannot find the area, but we know what the area is. So base times height is area, and we know the base, and we also know the area. That area should be congruent to this area right there, right? So we know these, and we only have one variable, so what would be the height? Problem number 11. In triangle ABC, measurement angle ABC is 90 degrees. H is the altitude, which is the height of this triangle. Well, also height could be this one or this one or this one, if you know, depending on which base you take. So if you claim that AC is your base, then the height has to be that line. But if you claim that the BC is the height, then you could say AB is the height. So here's what it says. Compare the quantities AC times H, so this times base times height, and AB times BC. Okay? Would AC times H be equal to AB times BC, or would AC times H will be greater or maybe smaller? Which one would that be? Problem 12, show that any triangle, the product of the length of a side, so take number 12, whatever the rectangle, I mean a triangle, why do I keep saying rectangle? Show that any triangle, the product of length of a side and the length of the altitude is the side of, to that side is the same for all three sides. So let's say any triangle ABCD, we have ABC. Now the height will be either